One more problem in physics, general physics. If you are preparing for your admission to engineering colleges in India, meant for JEE main and advanced only, not for NEET. What we'll be studying, not a general case, how power delivered depends on displacement of a particle. So, there is a force F acting on a body starting from rest. How this is starting from rest, I will tell you while integrating certain expressions. A force F acting on a body depends on its displacement S, where the F is given as F is proportional to S to the power minus 1 by 3, where F is the force, S is the displacement. The power delivered by F will depend on the displacement. There are 4 choices given: S to the power 2 over 3, S to the power minus 5 over 3, S to the power 1 over 2, S to the power 0, that is equal to 1. So before we proceed, I wish you already know the power is defined as power. P is equal to work done over time. Means if you do more work in less time, this is the fraction. If time is less, power will be more. Or you can write it as dW by dt also. If W depends on T, then you have to express this expression. If the value of W is known and T is known, then you just divide. Now since W is equal to work done is equal to for Fs cos theta, so divided by T, I divide this side with T, so S over T becomes velocity, so this becomes your F V cos of theta. Force is a vector, velocity is a vector, cosine of the angle. So this is your power. So your power is equal to same thing as your F dot V, a scalar quantity. Now, so what else you need to know while solving this problem? An important concept, let me explain you here, then I come back solving this problem. So if velocity is variable, changing with time, then you have acceleration. You did it like this in your school days. A is equal to final velocity minus initial velocity over time. Means what is the change in the velocity, the magnitude of the velocity per unit time. Or you can write A as dv over dt. Now what is interesting here, this can further be written as dv over ds, where ds is displacement, multiplied by ds over dt. I have not made any changes. I have divided by displacement ds and I have multiplied. So it remains same as dv over dt. By doing so, what this becomes, this part becomes velocity. So your acceleration is equal to v, this is your v, dv over ds. This is what is important, right? Acceleration is v times how the velocity is changing with respect to displacement. This will be using while solving this problem. Now, now let us come back to the problem. Since F is given as proportional to S to the power minus 1 by 3, so that can be replaced. So your F will be equal to some constant S over S to the power minus 1 by 3. Now, since force is equal to mass times acceleration is equal to k times s to the power minus 1 over 3. Now, now what we have to do here is you have to now replace this a with such an expression which I just explained you here. So this becomes m times a is equal to v dv over ds. So that is equal to the same thing as k s to the power minus 1 over 3. By doing so, why did I did so? For now, take this ds to the right hand side. So we are left with on the left hand side, we are left with mv dv. Means now this becomes integrable. ds comes to this side. So your case s to the power minus 1 by 3 ds. So now it becomes convenient to integrate. So let me put it in a box like this. Now if you integrate, because it is given starting from rest, so the limit of integration on the left hand side will start, lower limit will start with 0 and the upper limit will have some velocity v. Similarly, when it started from rest, it had not covered any distance. So the limit of integration on the right hand side will start from 0. So integration of mv dv starting from rest from 0 to velocity v will be integration of k s to the power minus 1 over 3 ds. That is from 0 to some displacement s. Now this becomes simple. Now m is taken out. Integration of v dv with respect to dv from 0 to v. K was the constant, proportionality constant, because it was given f is proportional to s to the power minus 1 by 3. And any constant in integration is taken out of the integration from 0 to s, s to the power minus 1 over 3 ds. So this becomes integration of v dv becomes v square by 2, its value from 0 to v. K comes to this side. So integration of s to the power minus 1 over 3 with respect to ds, the power will increase by 1, minus 1 over 3 plus 1 divided by minus 1 over 3 plus 1, its value from 0 to s. So now this becomes, I put the value of here, this upper limit, so v square by 2 minus, I put the lower limit, square of 0 is 0, 0 over 2, so this becomes k times s to the power, this becomes LCM is 3 minus 1, s to the power 2 over 3 over, take LCM, and then 3 plus of minus 1, that is equal to 2 over 3, and its value from 0 to s. So this will become 3 over 2. This 3 will come in the numerator and 2 will be still in the denominator. So 3 over 2 times k s to the power 2 over 3. If you put the limit, because this will not contribute, this part, the lower limit part will contribute 0. Now let me rewrite this in the next page. So this becomes half mv square. So this becomes half mv square. Half mv square is equal to half mv square is equal to 3 by 2 k times is equal to 3 by 2 k times s over 2 by 3. S over 2 by 3. Now, so what is the conclusion? Now these two cancels. These 2 cancels here with this. M multiplied goes to the other side, it will be divided. So we are left with v square. So your v square is equal to 3 by m k times s to the power 2 by 3. Now, so your v becomes the square root of this. 3 by m k, square root of this and square root of this term also. S to the power 2 by 3, its square root, I write it like this. So your v becomes, now this is a constant, this is a constant, this is a constant, so this whole thing is a constant. So it's a constant. So and this becomes s to the power 1 over 3. So velocity is equal to some constant s to the power over 1 over 3, means velocity is proportional to s to the power 1 by 3. And force we had, it was mentioned that F is proportional to s to the power minus 1 over 3. Let me rewrite here, and it was given force is proportional to s to the power minus 1 over 3. And your power, so we are interested in the power. Now, the power delivered. So, since power is equal to, which I just explained, power is equal to, was equal to your work done over time, that is equal to Fs cos theta over t. S over t is velocity, F times v. Cos of theta, cos theta is just a number. We are only interested in the proportionality. So from here, so P is proportional to F and proportional to V. So F is proportional to s to the power minus 1 by 3, and V we just calculated as proportional to s to the power 1 over 3 SS. So the power will be added minus 1 over 3 plus 1 over 3. So P proportional to s to the power 0. This is not a general case. This is not a general case. Under this particular condition, that is when F is proportional to s to the power 1 by 3, starting from rest, because I have taken the limit of the integration from 0, starting from rest. So when the velocity was 0 starting from rest, the initial displacement was 0. So this is not a general case. Under this condition, F proportional to s over s to the power minus 1 over 3, then power is proportional to s to the power 0. S to the power 0 is 1, means it does not depend on distance. You can try this for other expressions. For example, if you can take F proportional to s to the power